We're skipping all the fluff today, and we're diving straight into a massive exam trap. I mean, this is a trap that could literally cost you an entire grade boundary on paper 2 of your Cambridge Igcse Computer Science 0478 exam. So, let's get right into it.
Okay, let's set the stage with a little two-student duel. Imagine an exam question that's asking for a loop to process some user data. Now, on the left side of our imaginary exam hall, student A writes perfectly functional code. It loops, it compiles, the syntax is absolutely flawless, and it generally does what loops are supposed to do. But over on the right side, student B takes a completely different approach. They actually apply the specific syllabus constraints and deliberately weave the exact nouns from the scenario straight into their code. So who actually secures the marks here?
Well, to predict our winner, we really have to unpack exactly why ordinary run-of-the-mill revision completely fails for paper 2. We need to learn the very specific visual basic structures and the problem-solving logic that examiners actually demand. Listen, if you're just memorizing generic code snippets and regurgitating them onto the page, you're walking right into a massive trap. Why? Because generic memorization just doesn't map to dynamic problem-solving.
Section 1. Variables and Logic Core. Before you even think about writing a single line of Visual Basic, you absolutely have to nail down the theoretical foundations of your algorithms. Think about it. If your underlying logic is flawed, well, your code is going to be flawed too. The crucial takeaway here is that a variable is essentially your digital notebook. It tracks data that fluctuates as your program runs. Picture yourself doing a science experiment, right? You're recording the temperature of a chemical reaction, say every minute. Those temperatures are constantly changing, so your program needs a designated space, a variable, to store those changing inputs while the execution is happening. Now, on the flip side of that, we have constants. Constants literally lock your data securely in place, and this is absolutely vital when you want to ensure specific values never ever accidentally change during execution. Think of things like pi in a geometry calculation, or maybe a fixed discount rate in a store's checkout program. Once you set a constant, it stays set, giving you this super reliable anchor right in the middle of your code. And this brilliantly illustrates how pseudocode acts as a bridge to actual programming. Pseudocode uses everyday natural language, capitalized keywords like input or if, and indentation to show the start and end of your statements. But here is what makes Visual Basic so incredibly powerful for Cambridge students. Its coding syntax naturally mirrors this exact pseudocode logic. This is just a huge advantage for you in the exam room. It basically means less time mentally translating abstract concepts and way more time actively securing marks because your algorithm design seamlessly becomes your final program. Section 2. Visual Basic Structure and the Framework.
If you want to secure full marks in those written responses, you must follow this exact progression. Step 1, state the concept. Step 2, apply the specific evidence or data from the scenario. Step 3, provide your scientific reasoning. And step 4, finish it all off with precise examiner wording. Look, if you miss a single step here, you're just leaving marks on the table. For instance, step 4 doesn't just mean giving a technically correct answer. It means using the specific technical terms the mark scheme is actively hunting for. So you'd explicitly write the word iteration instead of just saying it loops.
And that brings us to a really massive pitfall. In just a moment, I'm going to reveal the hidden examiner clue that changes your loop structure completely. It's the exact clue that decides the outcome of our two-student duel. But setting up loops properly means knowing exactly what kind of data you're trying to let in or intentionally keep out. And that all starts with knowing how to thoroughly test your data.
Section 3. Interactive Coding Challenge and Testing.
Listen, examiners absolutely expect you to know exactly when to use different types of test data to try and break your program. Let's say system wants a user's age to be between 10 and 18. First, you need to deploy normal data, which is totally expected and accepted, like 15. Then you've got abnormal data, which is just the wrong format entirely, like literally spelling out the word TEN. Boundary data sits right on the edge of your acceptable limits, so that would be exactly 10 or 18. And finally, extreme data falls completely outside those limits, like putting in an age of 99. Knowing how to rapidly deploy these 4 types, that's totally non-negotiable for paper 2.
So once you run that data, you have to use a trace table to logically track your variables. Think of trace tables as your X-ray vision into the code. You're tracking memory states row by row, but here is the real trick. You must log how a variable changes after every single line of code is executed, not just at the very end of the loop iteration. Doing this definitively proves to the examiner that your iteration and selection statements actually work under pressure.
Okay, here is a huge trip-up point. Do not confuse validation with verification. I want you to pause and predict right now if an exam question asks you to ensure an email address has an @ symbol, are you using validation or verification? Take a second, lock in your answer in your head. Got it? You're using validation. Validation checks if data is reasonable or formatted correctly. Verification, on the other hand, checks if it is actually accurate, like making the user type their email address twice just to catch any typos.
Section 4. The Examiner Upgrade.
This right here is where the high achievers really separate themselves from the pack. We need to look closely at command words. If a question says state or define, be concise. Stop writing massive paragraphs. If it says describe, you need to give specific characteristics. Now explain requires both the why and the how. Compare, that means you absolutely must cover both sides of the argument. Moving up to the heavier tasks, if it says calculate, you have to show you're working out, and if it says evaluate, you must apply your answer directly to the given scenario. If you don't tailor your answers to these specific commands, you're going to drop easy marks, even if your underlying knowledge of the topic is rock solid.
You really want to memorize this exact answer template for your written questions. Start with the definition, followed by the mechanism, then the scenario example, the consequence, and finally wrap it up with that precise examiner wording. Always remember this golden rule: 1 mark usually equals 1 distinct technical point. Using this template completely prevents that dreaded waffling trap that so many students fall into when they're unsure. Where they just repeat the exact same point using slightly different words, hoping the examiner might just give them an extra mark. It doesn't work.
Section 5. Final exam strategy and the winner revealed.
All right, it is finally time to return to our two-student duel from the beginning of this explainer and reveal exactly who secured the grade. And student B takes the win. But why? Well, because they didn't just write functional Visual Basic code. Student B applied their logic directly to the scenario-specific nouns and constraints by using top-down design. Top-down design simply means shattering a massive, overwhelming problem into tiny, easy-to-code modules. Student A just wrote generic code that didn't reflect the specific problem asked in the exam paper at all. Student B hit every single mark scheme requirement by making their code incredibly scenario-specific. And honestly, that is the big examiner clue I promised you.
Being able to consistently act like student B and master these frameworks is the ultimate key to unlocking those top bands. So to ensure you don't miss any more of these absolutely crucial strategies, make sure you hit subscribe on our YouTube channel, Ace the Exams, at acetheexams_IGCSE to truly excel in your Cambridge examinations.
So you now have the framework, you know the validation techniques, and you understand the top-down strategy. But you really have to ask yourself, are you still studying like student A, just hoping that generic knowledge is going to save you? The examiners have already reported the devastating trap students are falling into this year. So check out the next explainer on your screen to uncover those exact mistakes and ensure your very next line of code actually secures the grade. Will you be ready?